Linear regression tries to determine if some kind of a linear pattern exists in our data set or not. So when we talk about data, it is very important for us to understand what we mean by it. So any kind of a data set has two parts to it, deterministic part and the random noise. So the deterministic part of the data corresponds to the broader pattern which emerges in the data, and the random noise is the haze of different data points which is scattered around the broader pattern which exists in the data. So any kind of an ML algorithm tries to map the broader pattern which exists in the data, and it is not possible for us to cater to the random noise which belongs to a particular data set. So when we talk about a linear regression, so basically we are trying to understand if a linear pattern exists in our data set or not. So a linear pattern could be in 1 dimension, 2 dimension, or in 3 dimension, and it is even possible that it might exist in more than 3 dimensions. From your school days, you might be able to recollect. We have learned the equation of a line when it is present in 2 dimensions, 3 dimensions. So when a line is present in 2 dimensions, then the equation for the line is represented by the function y equals to mx plus c. Here y is the variable that we are trying to predict. If it is a plane which exists in 3 dimensions, then the equation could be y equals to ax1 plus bx2 plus c. So x1 and x2 are two different coordinates, and with the help of these two features we are trying to predict the value of y. And if this particular line exists in more dimensions than 3, then a hyperplane is used to represent this plane mathematically. So equation for a hyperplane would look something like y equals to beta naught. Beta naught is the intercept of the y, plus beta 1 into x1 up to beta n into xn plus lambda. So here lambda is the random noise that we had talked earlier. So here these betas from beta 1 to beta n are the coefficients of all these features. So they represent the correlation between these features and our target variable. The more the values of these betas is, the more strongly and linearly these features are related to our target variable y. So now you can understand, if we change the values of these betas, then the entire line changes. So goal of a regression problem is to determine the optimum value of these betas. We also call them parameters. And once we have an optimum value of these parameters, we have the line of best fit, a line which is able to best model the pattern which already exists in our data. Now the question might arise, how do we find the line of best fit? The answer to that is we have two different algorithms at our disposal. The first is closed form solution, and the second one is known as gradient descent approach. So the closed form solution is applicable only for the case of a linear regression problem, but gradient descent is a more generalized approach which can be used for solving any kind of a ML algorithm. So now let us talk about how a closed form solution works. So in closed form solution, we take a line which tries to model the data that we have with us, and for the line that we have, we calculate the residual terms. So a residual term is a term in which we calculate the difference between the actual value of our target variable and the value which has been predicted by our model. So it is the subtraction of the actual value of y and the predicted value of y. For all these values, we take their squares and then we add them up. As a result, we get sum of squared errors. So this is a function. So now our goal is to minimize the sum of squared errors, and for the minimum value of this particular function, we want to calculate the values of the parameters. So as a result, at the end, we would be able to determine the parameters for the line of the best fit, a line for which the sum of squared errors is minimum.